The last thing I want to talk about very quickly is the idea of radiometric dating. Many of you are familiar with this process, but this is how we actually put these timelines, these years that I keep giving you. How are we coming up with this? Well, many of you are probably familiar with carbon-14, but all of the dates I have given you so far in the millions and billions of years cannot be dated with carbon-14. Carbon-14 dates well up to about 75,000 years, but beyond that, is very difficult to get accurate dating. We actually use potassium-40 to look at much longer time periods, much earlier time periods, because it has a half-life of about 1.3 billion years. This allows us to look at much more detailed dates much earlier on than anything that carbon-14 could possibly do for us. So when we look at half-lives, we start thinking about how long it takes for these different isotopes of carbon, isotopes of potassium to break down. Now, I said we could date carbon-14 out to about 75,000 years, and that's sort of really the outside for us as far as oldest fossils we could look at. Because when you look at this graph, we're looking at a half-life for carbon-14 at just about 6,000 years. So that means that every 6,000 years, roughly, you are losing half of your concentration. So half, half, half. Now, when we have that kind of decay or breakdown of these isotopes, we can't maintain a good carbon signature to be able to date these organisms, these fossils, these elements associated with them, and so on. So we'll get into this more a little bit later on and have you think more about why these differences occur. But just suffice to say at the moment that typically we're focusing not on carbon-14, but instead on potassium-40.